For this question, aluminum metal can be recycled from scrap metal by melting the metal to evaporate impurities. So for part A, we need to calculate the amount of heat needed to purify 1 mole of aluminum, originally at 298 kelvins, by melting it. So the original temperature is 298 kelvins. So to melt the aluminum, we need to raise the temperature from 298 Kelvin to 933 kelvins. And then we need to fuse the aluminum. So there are two parts. The first part is the heat needed to rise temperature from 208 Kelvin to 933 kelvins. So the delta temperature is 933 kelvins minus 298 kelvins, which is 635 kelvins. And the heat needed to rise temperature by 635 kelvins is 1 mole of aluminum times 24 joules per mole Kelvin and times 635 kelvins, which is 15,240 joules. And because 24 has two significant figures, so we change, so it's equal to 15,000 joules, which is 15 kilojoules. And for second part, the heat for fusion, Q equal to 1 mole of aluminum times the question told us the heat of fusion of aluminum is 10.7 kilojoules per mole. So we can just use this number. And the result is 10.7 kilojoules. So the total heat equal to 15 kilojoules plus 10.7 kilojoules, which is 25.7 kilojoules. So we need to have two significant numbers, so it's equal to 26 kilojoules. So it's the final answer. So the next question for part B. The equation for the overall process of extracting aluminum from aluminum oxide is shown below, which requires less energy, recycling existing aluminum or extracting aluminum from aluminum oxide. So first, to extract 1 mole of aluminum from the aluminum oxide. So in this equation, we can see that to extract 2 moles of aluminum, we need 1675 kilojoules. So extracting 1 mole aluminum requires 1675 kilojoules divided by 2, which is 837.5 kilojoules. And from the last question, we can see that recycling 1 mole aluminum requires 26 kilojoules, which is much smaller than the energy of extracting.